something. Just make sure I put my edges here. Forgot to do that. Okay. So we're going to talk about solving number word problems. We've already done consecutive integer word problems, right? And we learned that really cool trick of doing an algebraic approach instead of a guess and check approach. Now, with a problem like this, you could also use the guess and check method. You know, you could say, well, if this number was 1 and this was 3 times as large as the 1, then that would be 3. 1 plus 3 is 4, and that's wrong. So you could try 2, and you could do your guess and check until you get the right answer. That's one way. But since this is algebra, we're looking at ways to solve it algebraically, right? How to set these things up algebraically. It's a really, really useful tool. Before we do that, though, we have to talk about translating English into math. It's really, really an important concept. So if I said, if I said 4 more than X, what is that? How would I write that in algebra? So yes.
X plus 4?
Technically, no. Technically, no. What would you say,
Rowan? 4x?
No. More than, if I was 2 years more than you in age, you wouldn't multiply my age. I mean, your age. You would add. So he had the right idea. He just had the wrong order. Because, okay, Tom, what do you think? That's what Owen said. 4 plus 4. X plus 4. This would be X plus 4. So the words more than, that's something that you do to something. Do you agree with me? You're not going to take 4 and then add X to it. You're going to take X. This is your foundation. I can't say, Leo, did you guys know Leo was 3 more than? Did you guys know that? So you're all thinking, what? More than what? What? You got to know more than what? You got to have the what first. Well, what is the X? Does that make sense? You can't be more than anything until you first have that thing, right? So you write that thing first. And whenever it says 4 more than, you put that after the first thing. You put that at the very end. And the reason why it's important, I agree with Owen that 4 plus X and X plus 4 are basically the same thing. It's going to give you the same answer. But the reason why this is important, if you get in that habit of thinking when it says more than or less than or higher than or lower than, always put it at the end to the right of the foundational thing, which is the thing that you started with, the X. Because if I had done this, 4 less than X, and I had used Owen's approach, I would have done this, 4 minus X. But that's not true. Do you see that? It wouldn't be 4 minus X, it's X. It's what you had to begin with, and then 4 less than that. So you got to have X minus 4. That would give you a very different answer, depending on which way you wrote that. Does that make sense? You guys get that?
Yeah,
Okay.
So how would you solve X minus 4? You can't, right? What's it called? A binomial?
Yeah, it's just an expression right now. That is a binomial expression. There's no equal sign, so because there's no equal sign, there's no way I can solve it yet. Up here, it'll say something, and then it says their sum is 24. That tells me I can make it into an equation with an equal sign and then solve for X.
What if you had X minus 4 equals 1?
It's a good question, but hold on to it. Because what you're talking about is having 2 variables,
Yes.
and 2 variables that could be an infinite number of answers with 2 variables. And so that's not going to apply here because we're not going to have the y right now. There is a way to do this with y. Okay, what if I said 3 times as large as X? What would that be? Yeah, 3x. 3x. Times, the word times tells you immediately, right, that it's going to be times, right?
And then into, right, would be division. Like, if you see the word into.
Yeah, or what if I said this? What if I said the quotient of x and 3? What would that be? What does quotient mean? It's a division problem. It's the answer to a division problem, right? So that's going to be, which one? Is it x over 3 or 3 over x? What, say it again. It's x over 3. You always put the first number, when they say the quotient of, you put the first number in the numerator, second number in the denominator. So it would be x over 3, okay? What if I said the product of x and 3?
3x.
It would be 3x, right? What if I said the difference of x and 3? What would that be? What? Say it again. I didn't hear it. Yes. When they say the difference, you take the first one and subtract the second one from it. Okay? And then what if I said the sum of x and 3?
X plus 3.
Yeah. X plus 3. Exactly. It's not that hard, right? It's pretty straightforward. But sometimes you don't, it's just helpful to spell it out first so that then when we start to work with the word problems, it'll make a little more sense. Can I erase this?
No.
Not yet? Can I erase up to 3 times? I'm going to guess I can. Okay. Okay, are we ready? Can I erase all of it now?
Yeah.
Hold on. Okay. All right, so let's look at this question now. One number is 3 times as large as another. Their sum is 24. Find the numbers. Now there are ways to solve this with one variable, and there's ways to solve this with 2 variables, but I haven't taught you the 2 variable approach of systems of equations, and that's not going to be for a little while yet. So we're going to just use 1 variable approach to solve this, okay? Can I erase this now?
Yeah.
All right. So when you see this kind of a problem, one number is 3 times as large as another. Which is the base? Which is the foundational number? Is it the 3 times as large
Oh, it's
as,
24.
or is it another?
3 times
Oh, it's another.
Which is the foundational one?
Another.
I think it's
Because that's-
another.
Yeah, because you can't just say 3 times as large as
Right.
nothing. It has to be.
I
something.
can't say Raven is 3 times as large as, right? I can't say, I can't say that kind of stuff. I gotta know what, as what, right? It's the what first. So the another is your first thing, right? That's your foundational thing. So I'm gonna make my foundation, do I know what that is? Do I know that number? The another number? So I'm gonna make that my x. So it's almost always the last word in the sentence that becomes the x. Does that make sense? Right? One number is 3 times as large as another. So another is x. So my first number is x. You guys agree with me? And my second number, in terms of x, okay, I gotta have x in terms of it. It says the other number, this one, is 3 times as large as another. So what would I do? 3 times x. So my second number is 3x. Okay, so I have now used everything I can in the first sentence. Does that make sense? You see it? Does it make sense? Fist to 5. I just want to be sure you're all with me. Does it make total sense to you guys? Awesome. Okay. All right. Their sum is 24. What does that mean? Okay, so I have to add these 2 up. These 2 numbers. So I could do this. X plus 3x equals, is stands for equals, right?
Yeah.
Right? Do you guys know that? I didn't say that on that translating English to thing, but when you say the word is, it means equals. What if you saw the word was? Was. Or will be. Past tense or future tense of the verb to be, right? It's the same thing. Whenever, if you say they were, then that's equals. You see what I mean? Or will be, that's equals. But is definitely equals. X plus 3x is 24. Oh my gosh, now I have my equation.
Technically,
You can add the
couldn't
term.
couldn't you add like terms like
Yes. Okay, so what are my like terms? X and 3x, what's that?
that's 4x, but like then when you would divide it, it would be 6.
Okay, so we're going to solve for x, right?
Oh yeah.
We're dividing by 4, and we get x is equal to 6, right?
Yeah.
Now, there's supposed to be two numbers here, but I only got one number. Why?
Because
Yes,
you
Jack.
solve what x was, but you need to find what 3x is.
Oh, right. Because this is my little table that tells me what I'm doing. This is really important to write out. Then my first number is x, and my second number is 3x. Because then when I solve for x equals 6, I can come up here and say, oh, well, the first number is 6, and the second number is 3 times 6, which is 18. So those are my answers. But since it's a word problem, I have to write it in words, right? And it says find the numbers. So I would just say the numbers are 6 and 18, right? Make sense? It's not too earth-shattering, right? It's not too hard, right? Can I erase?
Yes.
Really? Everybody's okay with that? Okay, we're gonna do one more just to practice. Whoops. Let's see. Okay, I guess I do have to erase that. One number, I'll just erase that. One number is, okay,
This is number 2, right?
this is number 2. Thank you so much for saying that. Number 2. One number is 2 more than 3 times another. Their sum is 30. Find the numbers. So just like in the last one, it says one number is 2 more than 3 times another. What's the foundational thing?
Another.
Another is the foundational thing, right? If I know the another, then I can figure out the 2 more than 3 times, right? But this is my foundational thing, so I'm going to make that what?
X.
That's my x. And that's over here, I'm creating my table, and I say my first number is x. And my second number, this is the hard part, second number, it says it's 2 more than, there's that word, 2 more than. Where does the more than go again? Off to the right. Remember, when you see more than, less than, higher than, lower than, it goes off to the right. Okay? So I know it's going to be off to the right. How do I write 2 more than?
So it'd be 3x plus 2. Right?
I'm going to write my plus 2. And yes, 3 times the other. That would be my 3x. So it would be 3x plus 2. Does that make sense?
Yep.
2 more than, that's the plus 2 off to the right. 3 times the x. 3x. That make sense? Got it? Okay, and then it says their sum is 30. So x plus 3x plus 2 equals 30, right?
Add the like term.
Okay, x plus 3x is
4.
4x plus 2 equals 30. What do I do now?
Minus 2.
Minus 2, minus 2. 4x equals 28. Now what?
Divide by 4.
Okay, x equals 7. And I'm done, right?
Mm-mm.
No, it says find the numbers. Always go back. With word problems, get in this habit. This will save you a lot of bad grades. If you promise yourself and force yourself to always go back with every word problem and reread the last question. It says find the numbers, that's plural. So I'm going to go back to my table that's right here. My first number is 7. My second number is 3 times 7 plus 2. What would that be? 21, 22, 23, right? So those are my two numbers. So the numbers are 7 and 23. And I put it in a box so the teacher can see it. And we are done. We did it. You can make sense? Just to 5? You guys all cool with this? Yes?
Yeah.
All right. So we're done with the lecture. I'm going to just give